Exposing the truth in cancer therapy. Did you know grapes and gold might be the superheroes we never expected? Here's how they're changing the game. For years, cancer treatment was all about blasting away disease, often harming healthy cells along the way. But what if we could outsmart cancer, instead of just attacking it? Enter a natural compound from grapes called resveratrol. Scientists discovered that when you combine it with tiny particles of gold, yes, real gold, you get a powerful tag team. This duo can seek out prostate cancer cells, deliver a precise dose of radiation, and even let doctors track the treatment in real time. It's like giving medicine a GPS and a secret weapon rolled into one. Could this be the future of cancer therapy? Stick around, because on For Science Salah Lotfy, we're breaking down breakthroughs, one golden grape at a time.
Welcome to For Science Salah Lotfy channel, where global scientific research becomes clear and accessible.
هنا نحول الأبحاث العلمية العالمية إلى معرفة مبسطة مترجمة لك بلغتك.
Ici, la science est expliquée et traduite pour tous.
Ciencia clara, accesible y disponible en varios idiomas.
Wissenschaft, verständlich und mehrsprachig für jeden.
قناة For Science Salah Lotfy Channel. العلم للجميع وبجميع اللغات. تابعنا لاكتشاف المزيد.
Welcome back to the channel, where I take you inside the world of cutting-edge science. Today I'm diving into some truly groundbreaking research published in the Journal of Materials Chemistry B, a big name in both materials science and biomedical research. This study from 2025, volume 13, pages 8038 to 8050, is all about advanced nanomedicine and radiopharmaceuticals, fields that are pushing the boundaries of cancer treatment. Let's start with the title. It's a mouthful, but stay with me. Immunomodulatory, green, nanomedicine production, tumor cellular targeting, in vivo biodistributions, and preclinical therapeutic efficacy investigations of resveratrol-functionalized gold and theranostic gold 198 nanoparticles. In simple terms, this research is about designing smarter, greener nanoparticles, tiny particles that can seek out tumors, deliver treatment, and even help image cancer inside the body, all while being more compatible with the immune system. This international collaboration brings together nuclear science, medical imaging, nanotechnology, and green chemistry. Here's who made it happen. Professor Dr. Tamer Sakir, from the Radioactive Isotopes and Generator Department at the Hot Labs Center, Egyptian Atomic Energy Authority in Cairo, and the Department of Radiology at the University of Missouri, Columbia, USA. Professor Dr. Valafi Thaip, Department of Radiology and Institute of Green Nanotechnology, University of Missouri. Professor Dr. Kavita Katti, from the University of Missouri and Indus University, India. Professor Dr. Lisa Watkinson and Professor Dr. Terry Carmack, both at Harry S. Truman Memorial Veterans Hospital and Molecular Imaging and Theranostics Center, University of Missouri. Professor Dr. Charles Smith, also at the same hospital, the Molecular Imaging and Theranostics Center, and the University of Missouri Research Reactor, MURR. Professor Dr. Kathy Cutler, Isotope Research and Production Department, Brookhaven National Laboratory, Upton, USA. Professor Dr. Prajna Hegde and Professor Dr. Anantkumar Hegde, Kadamba Interact Private Limited, Bangalore, India. Professor Dr. Ademar Lugão at Instituto de Pesquisas Energéticas e Nucleares, Brazilian National Nuclear Energy Commission, São Paulo, Brazil. And finally, distinguished curators Professor Dr. Katesh Katti from the University of Missouri, Indus University, and the University of Johannesburg, South Africa. The team credits major support from the Missouri University Research Reactor, the Institute of Green Nanotechnology, the International Atomic Energy Agency, the Fulbright Program, Brookhaven National Laboratory, IPEN Brazil, and Kadamba Materials, India. This publication is a powerful example of how global science can unite to tackle cancer, blending expertise in nanomedicine, radiopharmaceuticals, and targeted therapy. In the next parts of this episode, I'll break down what this research actually means, how these nanoparticles work, and why this matters for the future of medicine and technology. This is For Science Salah Lotfy channel, where published research meets clear scientific understanding. Don't forget to subscribe if you want to keep up with the latest in science. Have you ever wondered why, despite all the incredible advances in modern medicine, prostate cancer remains such a formidable challenge? It's a question that puzzles not just patients and their families, but also doctors and researchers around the world. Prostate cancer is not only one of the most common cancers affecting men globally, but it's also one of the most complex to treat effectively. Even with decades of research and countless medical breakthroughs, prostate cancer continues to impact millions of lives every year. The disease can be unpredictable, sometimes slow-growing and manageable, other times aggressive and life-threatening. This unpredictability makes it difficult for doctors to know exactly how to treat each patient. Treatments like surgery, chemotherapy, and radiation therapy have saved countless lives, but they're far from perfect. Each approach comes with its own set of risks and limitations. Surgery can be invasive and may not remove every cancer cell. Chemotherapy and radiation can damage healthy tissues, leading to side effects that can be tough to manage. So why do we still see problems like cancer relapse, where the disease returns after treatment, or harsh side effects that impact a patient's quality of life? The answer lies in the hidden complexity of prostate cancer itself. Cancer cells can hide in the body, evading even the most advanced treatments. The real challenge is precision. Traditional therapies, while powerful, can sometimes miss tiny clusters of cancer cells or unintentionally harm healthy tissue nearby. This lack of accuracy is a major reason why some patients experience relapses or suffer from unwanted side effects. Imagine if doctors could see every single cancer cell, no matter how small, and target it with pinpoint accuracy. This level of precision could revolutionize how we treat prostate cancer, making therapies more effective and reducing the risk of side effects. That's where the latest breakthroughs in science come in. By combining the power of nanotechnology with the precision of nuclear medicine, researchers are developing smarter, more targeted treatments. These innovations offer new hope for patients and could finally tip the balance in our fight against prostate cancer.
When you think of nature, you might picture a quiet forest or a juicy grape on a vine. Calm, alive, and familiar. Nature is full of complex systems shaped over millions of years. Now think about nuclear science, giant power plants, invisible energy, and the tiniest building blocks of the universe, atoms. It feels like a world apart from nature, all machines and equations. On the surface, these two worlds, nature and nuclear science, seem like opposites. One is slow and organic, the other high-tech and powerful. You wouldn't expect a connection between a berry and a nuclear reactor. But science thrives on unexpected connections. Today, scientists are combining the wonders of nature with the power of nuclear technology. This surprising partnership is opening new ways to solve big problems, especially in medicine. It's a team-up you'd never expect, but it could change everything. The special ingredient from nature, resveratrol, a molecule found in red grapes, blueberries, and peanuts. Plants make resveratrol to protect themselves from stress, acting as a natural shield. In our bodies, resveratrol is a powerful antioxidant, protecting our cells from damage. It also helps reduce inflammation, calming the body and promoting health. Because of these abilities, scientists wondered, could resveratrol help fight cancer? In lab studies, it slowed cancer cell growth and made them more vulnerable. This sparked a new idea. What if this natural protector could help us target cancer more effectively? The question led to a whole new area of research. By combining resveratrol's natural defense with advanced science, we might unlock better treatments. Sometimes, the smallest molecules can make the biggest difference. And that's where the story gets even more interesting. Here's where nuclear science joins the story. Scientists needed to deliver resveratrol and a cancer-killing treatment directly to tumors. Their solution: gold nanoparticles, thousands of times smaller than a human hair. These tiny particles can travel through the bloodstream and gather in tumors. But they took it further, using a radioactive form of gold that releases cancer-fighting energy. Then, they coated these particles with resveratrol. The result? A smart particle that targets cancer cells more precisely. Cancer cells are drawn to resveratrol, helping the gold reach the tumor. Once there, the radioactive gold attacks, while resveratrol makes cancer cells more sensitive to treatment. It's a 1-2 punch. Resveratrol weakens the cancer, and the gold delivers the blow. Together they form a powerful, targeted therapy. Why does this matter? Traditional radiation therapy can harm healthy tissue along with cancer. The golden grape particle changes that, guiding treatment directly to the tumor. It's like upgrading from a sledgehammer to a laser-guided tool. More precise targeting means fewer side effects and better outcomes for patients. This partnership shows how nuclear technology can be made safer and more effective with help from nature. Resveratrol acts as a biological guide, directing powerful energy exactly where it's needed. The synergy between nature and science is a huge leap forward. It's proof that answers to big challenges can come from unexpected places, even a grape. By exploring these partnerships, we can create treatments that are both powerful and gentle. That's a future worth getting excited about. If you want to see more breakthroughs like this, don't forget to subscribe to the For Science Salah Lotfy channel. Delivering medicine to the right spot in our bodies is a huge challenge. Imagine trying to deliver a letter to one house in a massive city without a map. Enter nano-radiopharmaceuticals, not just a pill, but a tiny, programmable robot on a mission. These are multifunctional platforms. Think Swiss Army knives at the nanoscale. They navigate our bloodstream, find specific targets, report their location, and act, all in one. Their power comes from their size. A nanometer is a billionth of a meter, smaller than a virus. This lets them interact directly with cells, where diseases like cancer begin. By working at this scale, treatments become far more precise and effective. So, nano-radiopharmaceuticals aren't just drugs. They're delivery vehicles, tracking beacons, and therapeutic agents in one. This is a leap beyond the old one-size-fits-all approach. It's about sending in a specialized team to do a job with incredible precision. We're building medicine on the same scale as life itself. This is the future of targeted, smart medicine. Science is getting smaller and smarter. Get ready to see how it works. What makes nano-radiopharmaceuticals so powerful? They're built from 3 parts, each with a unique job. First, the targeting system. Special molecules on the nanoparticle act like guided missiles, locking onto diseased cells and ignoring healthy ones. Second, the therapy. A radioactive isotope delivers a precise, controlled burst of energy to destroy the target cell, no collateral damage. Third, imaging. The same isotope emits a signal doctors can track in real time, like a live GPS for your medicine. These 3 parts work in harmony: target, treat, and track, all in one tiny package. It's a complete, self-contained system for fighting disease with accuracy and control. This isn't just medicine, it's medical engineering at its finest. Imagine doctors watching treatment happen, adjusting as needed. That's the promise of nano-radiopharmaceuticals. Let's see this in action, with gold. Scientists create gold nanoparticles, billions of which fit on a pinhead, and coat them with targeting molecules. They load these with a radioactive isotope, gold-198, which does 2 things: releases short-range beta particles to destroy cancer cells, and emits gamma rays for imaging. Injected into the bloodstream, these gold nanoparticles seek out tumor cells, latch on, and deliver their radioactive payload right where it's needed. The beta particles destroy the tumor from within, while gamma rays let doctors watch the process on a scanner. Doctors see exactly where the drug goes and how the tumor responds, no guesswork. It's a precise, elegant system. Gold becomes a tool for healing. This is targeted therapy and real-time monitoring, all in one. The result? More effective treatment, fewer side effects. That's the power of nano-radiopharmaceuticals in action. Combining treatment and diagnosis in one system is called Theranostics, a blend of therapy and diagnostics. In the past, diagnosis and treatment were separate. Now, they happen together, in real time. Doctors watch the medicine reach the tumor, confirm it's working, and adjust instantly if needed. This means more precise, personalized care, and fewer side effects. Radiation targets only the cancer, sparing healthy tissue. Real-time tracking gives doctors invaluable data to tailor treatment for each patient. Theranostics is already changing cancer care in labs and clinics worldwide. We're moving from carpet-bombing disease to precision strikes. The future of medicine is smarter, safer, and more effective. Science, technology, and medicine are joining forces, and it's changing the world, one tiny particle at a time. If you enjoyed this journey into the future of medicine, don't forget to subscribe to the For Science Salah Lotfy channel for more fascinating science stories.
When we think of gold, we picture shiny jewelry or coins, a symbol of wealth. But in science and medicine, gold 198 is saving lives. This isn't treasure chest gold. It's a radioactive isotope used to fight cancer. Doctors harness its energy to target and destroy cancer cells. Gold 198's radiation allows for a precise attack on tumors, sparing healthy tissue. This is science in action, transforming gold into a medical superhero. Gold 198 is more than just shine, it's hope. What makes gold 198 so special? It emits two things: beta particles and gamma rays. Beta particles are high-energy electrons that travel only a few millimeters, perfect for attacking nearby cancer cells. When a beta particle hits a cancer cell's DNA, it disrupts the cell's ability to grow and divide, stopping the tumor in its tracks. This is targeted destruction, cell by cell. Gold 198's second superpower is gamma rays. Gamma rays travel farther and act as a tracking beacon. Special cameras detect these rays, letting doctors see exactly where the gold 198 is inside the patient. It's like having a GPS for cancer treatment. The beta particles destroy the tumor, while gamma rays guide the therapy. Doctors can confirm the radioactive gold is in the right place and monitor progress in real time. This dual action, therapy and imaging, makes gold 198 a game changer in nuclear medicine. One isotope, two powerful roles. That's why gold 198 stands out. Timing is everything with radioactivity, and gold 198's half-life is about 2.7 days. The half-life is how long it takes for half the radioactive atoms to decay. For cancer therapy, 2.7 days is ideal, long enough to prepare, deliver, and treat, but short enough to limit exposure. If the half-life were too short, the isotope would lose its power before reaching the patient. Too long, and it would linger dangerously in the body. Gold 198's half-life strikes the perfect balance: effective treatment, minimal risk. After about 27 days, the radioactivity is nearly gone, making it safe for the patient. This predictable decay means the radiation is present when needed and fades away quickly. The timing allows for maximum tumor destruction and quick recovery. It's a built-in safety feature, dictated by physics. Doctors can use gold 198 confidently, knowing the danger disappears naturally. The 2.7-day half-life is a key reason gold 198 is so effective and safe. Smart timing, smart medicine. How do we make sure gold 198 targets only the tumor? By putting it inside a tiny gold nanoparticle. These nanoparticles act as delivery trucks, carrying radioactive gold right to the tumor. The beta particles from gold 198 travel only a short distance, focusing radiation on the cancer. This protects healthy tissue and maximizes the attack on cancer cells. It's like a precision strike, not a carpet bomb. The tumor's leaky vessels trap the particles, concentrating radiation where it's needed. It's a clever, safe, and potent way to fight cancer. Gold 198 brings together physics, chemistry, and biology for a smarter cancer treatment. It was chosen for its unique radioactive properties, delivering both therapy and imaging in one. Beta particles destroy tumors. Gamma rays let doctors track the treatment in real time. This combination, called Theranostics, is a leap forward in cancer care. The short 2.7-day half-life ensures powerful treatment with quick, natural fade-out for safety. Gold-198's self-limiting nature means less risk for patients. Nanotechnology adds precision, keeping radiation locked onto the tumor and sparing healthy tissue. It's a targeted approach, reducing side effects and improving outcomes. This is the future of personalized medicine. Effective, gentle, and smart. Gold-198 maximizes tumor destruction and minimizes harm to the rest of the body. Doctors gain control and confidence, seeing exactly where the treatment is working. Gold-198 isn't just gold. It's a golden opportunity for safer, better cancer therapy. Science at its most brilliant, saving lives. If you found this fascinating, don't forget to subscribe to the For Science Salah Lotfy channel for more breakthroughs and discoveries.
The star of this story is resveratrol, a powerful antioxidant found in the skin of grapes. You may have heard about it as the healthy part of red wine, but its talents go far beyond heart health. In the lab, resveratrol is proving to be a multitasking marvel, playing not one, but 3 crucial roles in the fight against cancer. First, think of resveratrol as a green chef in a molecular kitchen. Instead of using harsh, toxic chemicals to create gold nanoparticles, the tiny particles that can be used to deliver medicine, resveratrol does the job naturally. It helps cook up these gold particles in a way that's safer for both people and the planet, making the process eco-friendly and sustainable. Second, resveratrol acts like a protective wrapper. Once the gold nanoparticles are formed, it coats them, giving them extra stability. This means the particles can travel safely through the body without breaking down or clumping together, which is essential for delivering medicine exactly where it's needed. But here's where things get really interesting. The real magic happens because cancer cells are especially attracted to resveratrol. They recognize it and eagerly absorb it, almost like a treat they can't resist. Scientists realized they could use this craving to their advantage. By attaching cancer-fighting drugs to these resveratrol-wrapped gold nanoparticles, researchers have created a kind of guided missile. The cancer cells gobble up the particles, unknowingly taking in the medicine that's designed to destroy them. This makes the treatment much more precise, targeting tumors while leaving healthy cells unharmed. A huge leap forward in cancer care. So, by combining the natural power of resveratrol with the cutting-edge technology of gold nanoparticles, scientists are opening up a new frontier in cancer treatment. It's a perfect example of how nature and nanotechnology can join forces to create smarter, safer, and more effective therapies for the future. If you enjoyed this video, don't forget to subscribe to For Science Salah Lotfy channel for more fascinating science stories and discoveries.
Imagine a world where a tiny mouse could hold the key to revolutionizing cancer treatment. It might sound like science fiction, but right now, in research labs across the globe, scientists are making discoveries in mice that could change the way we fight cancer forever. These small creatures, often overlooked, are at the heart of a medical breakthrough that could impact millions of lives. So, what exactly is this breakthrough, and how did it all begin with lab mice? Let's dive into the details. Scientists have been working tirelessly analyzing data and discussing their findings to uncover new ways to target cancer more effectively. Their goal? To find a treatment that destroys tumors without harming the rest of the body. After years of research, they stumbled upon something remarkable in their experiments with mice. Here's what they did. In a series of carefully controlled experiments, researchers injected a special radioactive dose directly into the prostate tumors of lab mice. This wasn't just any treatment, it was designed to target the cancer cells with pinpoint accuracy, delivering radiation exactly where it was needed most, while sparing healthy tissue. The results were astonishing. Over 85% of the radioactive dose stayed locked inside the tumor, barely affecting vital organs like the brain or heart. This level of precision is something doctors have dreamed of for decades, as it means fewer side effects and a safer treatment for patients. But the most exciting part? The tumors in treated mice shrank more than 10 times compared to those in untreated mice. Even more impressive, the mice showed no major side effects or damage to their healthy organs. This suggests that the treatment is not only effective, but also safe, a rare combination in cancer therapy. These groundbreaking findings prove that targeted radiation can attack cancer cells with incredible accuracy, leaving the rest of the body unharmed. If these results can be replicated in humans, we could be on the verge of a new era in cancer treatment, one where hope replaces fear and precision medicine becomes the new standard of care. If you found this breakthrough as fascinating as we did, don't forget to subscribe to For Science Salah Lotfy channel for more amazing science updates and discoveries.
When we hear about breakthroughs in medical research, it's tempting to focus on a single disease, but the real story is a shift in how we approach treatment itself, a revolution in medical philosophy. For decades, cancer treatment relied on overwhelming force, powerful chemotherapy and radiation, often harming healthy cells. Now, research is pioneering a path that values precision over power, intelligence over brute force. A strategy developed for one cancer can often be adapted to others, like designing a master key for many locks. Lessons from prostate cancer research, for example, are creating blueprints to tackle a wide range of cancers. Each breakthrough strengthens our fight against all diseases, not just one. We're building a new arsenal of treatments, smarter, kinder, and more effective. This isn't just about adding tools, it's about redesigning the entire toolbox for the challenges of the 21st century. The progress we make for one patient group is a leap forward for all of medicine. The future of treatment is about universal innovation, benefiting everyone, regardless of diagnosis. At the heart of this revolution is a simple idea: less is more. Instead of flooding the body with high doses, we now use smaller, targeted amounts of medicine. Advances in nanotechnology let us deliver drugs directly to cancer cells, sparing healthy tissue. These microscopic delivery vehicles act like smart bombs, homing in on their targets. This approach is more effective and gentler on patients, reducing side effects. Theranostics, combining diagnosis and therapy in a single step, lets doctors see and treat cancer simultaneously. We're moving from carpet bombing to precision strikes, changing the entire experience of cancer treatment. It's a complete reimagining of how we fight disease, calculated, precise, and with minimal collateral damage. Precision medicine is unlocking truly personalized cancer care. Instead of one-size-fits-all protocols, treatments are tailored to each patient's unique biology. Diagnostic agents reveal the specific traits of a tumor, guiding targeted therapy. This means fewer side effects and a higher quality of life during treatment. Patients can stay stronger, continue daily life, and spend more time with loved ones. Using smaller, targeted doses also makes these therapies more sustainable and accessible. Every resource is used efficiently, helping more people with less waste. Personalized care empowers patients, giving them control and hope during their journey. The future of medicine is about restoring dignity and choice to those facing life's toughest challenges. Progress in cancer treatment isn't about stronger drugs, it's about smarter design. The new era of medicine is defined by elegance, efficiency, and intelligence. Why treat the whole body when a microscopic messenger can target just the disease? This approach respects the body's complexity and seeks harmony, not destruction. Precision targeting and personalized therapy will impact not just cancer, but infectious diseases, chronic conditions, and tissue repair. The lessons learned here are building a foundation for a new generation of medicine, more effective, less invasive, and tailored to the individual. We're moving beyond blunt instruments into an age of medical artistry. The future of medicine is smarter, not harsher, where healing is matched by wisdom. Understanding these advances is the first step toward a healthier world. Stay inspired by the progress shaping the future of healthcare. If you enjoyed this video, don't forget to subscribe to the For Science Salah Lotfy channel and share your thoughts about the research in the comments below. We'd love to hear from you.